We're going to have a quick look now at free surface effects. And the free surface effect occurs when you have a vessel with slack tanks that's inclined, and the water in the slack tank, or the liquid, sloshes over and creates a situation where your righting lever is reduced and you suffer an apparent loss of GM. In the first sketch in the corner here, with a vessel in port and the double bottom tank is just half full, and you might just be able to see there a little letter G, which represents the centre of gravity of the liquid in that double bottom tank. So when the vessel's in port, no problem at all, she's upright in port and the water is a liquid is in the tank and the centre of gravity of the liquid is on the centre line. Then this same vessel sails out to sea and heels over due to an external force. So what happens is all the water that is in the double bottom tank now rushes over to what would be our starboard side in this particular vessel. So it's all rushed over to starboard. So the first thing that happens as the vessel inclines, G moves to G1. So the centre of gravity that was there of this liquid in the tank has now moved over to G1. Then G moves parallel to and in the same direction as G1, or as the liquid that's moved. Okay, so G moves parallel to and in the same direction. So now we have G1 Z1. So originally GZ here was our righting lever, and because G has moved over parallel to and in the same direction, G1 Z1 is now our new righting lever, and you can see that it's a different size from the original righting lever. It's obviously smaller, it always is smaller, and therefore our ability to right ourselves has been reduced. This is a real loss, so we suffer a real loss of our GZ or righting lever. It's important that you get this right. GZ is a real loss, and if you think of yourself on the vessel, that makes sense, because as you heel over, the ability of the vessel to come back upright has got to be compromised by this water sloshing and moving over. However, as number 4 indicates, G remains on the centre line. Our centre of gravity is still on the centre line of the vessel. Now we know that the definition of a righting lever is the perpendicular distance between the buoyancy force and the weight force. Okay, so because our righting lever is reduced, then G must still be on the centre line, so G1Z1 moves up to GVZV. So the size of G1Z1 is the same as GVZV, but it must move up until it sits between the buoyancy and the weight force. So you've got the weight force and the buoyancy force, and that sits between the two, and that GVZV is the righting lever. I hope you can see that. Because G remains on the centre line, G1Z1 must move up to GVZV. So GZ was the real loss, and as GM moves to GVM, this is an apparent or virtual loss of GM. So originally the GM of the vessel was from G through to M here. Now it's GV to M. So we've actually suffered a virtual or apparent loss of GM, and it's that value there that is the amount that we've lost, and it's important that you state that it's virtual or apparent. You don't need to go too deeply into it, you just need to definitely don't get these two mixed up. Your GM is apparent or virtual loss, your GZ is a real loss. And if you must be able to remember this, but just think of yourself on the vessel, your righting lever has to be reduced. That's a real loss. So GZ is a real loss, but GM is an apparent or virtual loss. And this value, G to GV, represents the free surface effect. So when we talked about the free surface effect originally, that is the actual real value of it, G to GV. And free surface effect can be stated as FSMs, or free surface moments, in tonimeters, or FSC, which is free surface correction, in meters. And simply FSC would be these moments here divided by the displacement of the vessel, which will give you the free surface correction. And when you're applying the free surface correction, well, your GM, you must always subtract the free surface correction from your GM, because it's reducing that amount. Okay. With the moments, when you do your table and you've got moments, you have the weight, kg moments, and you get your total moments divided by the total weight to get your kg. You must always add these moments. The reason you add them, of course, is that if the moments are increased, the kg must increase, because we know that kg is total moments over total weight. So if you've increased the moments, you're going to increase the size of kg, and if you increase the size of kg, you're reducing the size of GM. So also don't get those mixed up. Free surface correction, always subtract from the GM, and free surface moments always add to the moments table. So that's free surface correction.